Hey guys, it's Damien here, and I want to discuss with you how I was able to design this in a way where I could be extremely efficient as well as take shortcuts to not have to waste so much time printing. So originally I started off with parts which are all available on Thingiverse and Printables, but I started off with parts making sure the hole locations and the geometries are correct, and then I slowly ended up mating them together and started to align the holes in CAD to make sure that I could get something similar to this. But before I started with this, I actually simplified the design, and instead of having all these complex curves, I pretty much straightened out the edges where it wouldn't interfere with anything. This is the first prototype I've ever made. I don't think I've actually posted this, just to see if I could make multiple parts and see if I could get a one-piece chassis, which I did. Originally it was slanted, and I didn't like the fact that it made a bunch of steps, so I straightened everything out. So after I realized that something like this was possible, I ended up cutting down the most important locations to be able to build this 3D printed helicopter. And I started off with something like this. I pretty much cut down every area that I did not need to print to save on print time and increase the time that I could print and test out my hole locations, because I wanted to make sure that I could just put in the motor and the servos, the entire top section of the helicopter, and be done with it. So one of the things I ended up doing is I ended up printing walls instead of using organic support structures or the grid support structures. I just extruded some geometries where I wouldn't have to use the supports that it were included, because sometimes they could get finicky. So I ended up designing multiple areas of supports so that I wouldn't have to use the slicer ones, which ended up saving me some time. And then I'll show you guys a close-up shot, but I had a bar here to support the arms in the front of the helicopter, and then I ended up just cutting them off, making them super thin, just enough to support that overhang. So I ended up printing this specific design a few times just to make sure that I could fit it onto the bearing block the bearing blocks and make sure that the hole locations were right, and then I slowly started to focus in other areas. One of the other areas, sorry, I'm going back and forth here. One of the other areas I focused on was the battery compartment. So I pretty much took the design and just eliminated all the areas that I did not need, and then focused on the battery location. And I did this multiple times. And when I was doing this, I was pretty much trying to tolerance the areas that I needed that were the most important, which was the orientation of the battery. Most people have been putting the Goose Sky battery like this, so I've been pretty much focusing in to make sure that the battery fits the battery compartment. But the original design actually has a protecting bracket here in the front, and I didn't want to use that just because that was just more geometries I did not want to include on the design. So what I ended up doing is I roughly dimensioned out the battery and then slowly increased the parameters or decreased the parameters to tolerance the battery fitment in this airframe to a point where it would be a nice tight fit, not ruining the battery, because these batteries are very delicate, in a way where it would just snugly fit into the frame. One of the things that you do have to worry about as far as items in the real world, they're not all perfectly dimensioned. You might have 24 millimeters on this end and then maybe 24 and a half millimeters on this end. So that's why I kept printing out multiple compartments just to make sure that the fitment check is perfect. Sometimes you could design something like this in CAD and just have a rough idea, which also saves you time, but CAD design doesn't always translate to real life objects that you could use and fit into your design. So that's one big thing that I would recommend, is just cutting apart your design in small specific areas you need to focus on to be able to make those fit checks that you need. Another design that I've actually cut down quite substantially, which I don't have samples of, is this tail boom. So originally when I was putting this horizontal bar in the tail boom, I wanted to make sure that it was in the right location, it was fitting, and that the screws were going through and being able to hold onto that tail boom section with the vertical stabilizer, so pretty much I cut out the important section that was extremely important, screwed this on, and then just made sure that the alignment and the orientation of where it's supposed to be on that tail boom fits, and it just looks right. I mean, I could pretty much go through the majority of the helicopter, but I'll give you two more examples. The tail boom block and the tail boom itself. I was making sure that the dimensions of the boom itself would fit the tail boom block nicely. And in CAD, it might be absolutely perfect, but in 3D printing, you have specific tolerances. I think it's 0.2 millimeters in plus or minus 0.2 millimeters. I might be wrong on that, don't quote me. But you print out a bunch of these small items and small sections of the tail boom to make sure it fits. And sometimes there might be gaps. It might not be absolutely perfect, but you could get as close as you possibly can to make sure that the fit, form, and function of the part is what you need it to be. So that was one thing that I also focused in on, is the tail boom and the tail boom block. One last thing that I'll mention to you guys, and if you have an idea of exactly what part I'm going to be working on, I will not let you know until later, but one item I was recently printing is this small square with a cutout section to fit a bearing. So you measure the bearing, make sure it's exactly what you need it to, and it'll fit. But sometimes if you need a tighter fit, then you slowly start dimensioning those holes or those areas that you need, it maybe 1/10 of a millimeter or less, and then just start. So I believe this was 10 millimeters, and then you wouldn't notice, but for example, this hole is 9.9 millimeters, and then you do another fit check, and for example, that fit check of the bearing going into this plastic piece is a lot tighter. You could, push it to 9.8, 9.75, and keep going down until you just can't fit the bearing anymore if you're really trying to make functional designs like this. But you could also, I haven't tested this out, but you could also pause a print and put your hardware in, and then it'll eventually print over that hardware so that you have an embedded piece in a 3D printed part, which I haven't messed with, something I want to work on. But if you know what part I'm going to eventually be working on just by this clue, mention it in the comments below. I'm kind of curious on what you guys think. I hope that anybody in the RC helicopter world has an idea of what I'll be working on, but I will mention that in a different video. But that's pretty much all I have. There's a lot more ideas that I've worked on as far as trying to focus in and hone in a small area, and then make sure that the dimensions and geometries are correct, making sure fit checks are correct, making sure that the hole locations are correct. But if you do have any questions as far as CAD designing, how I was able to go from AutoCAD to the physical 3D printed part itself, please comment down below. I'd love to help you guys, or if you guys are just curious or have the curiosity of how I ended up getting here, let me know. I don't mind reaching out, but if you guys like this type of content, please like and subscribe, and I'll catch you guys in the next one. Thanks for watching.